Welcome back. In this video, we're going to go over the answers to pages 132 through 136. When we left off, we had worked on page 131, and we were working on the climbing El Capitan, the sheer cliff in Yellowstone National Park. And again, when we arrived to watch the climbers try to beat the record, they're exactly halfway up the 3,000-foot climb. So they're at 1,500 feet. To beat the record, they plan on climbing on average 20 feet every minute. So X is our input value. That's the number of minutes. And their total height at any given time will be Y. Y is the height of the climbers in feet. Now, El Capitan is 3,000 feet. So the highest they can go is 3,000. They're not going to climb to 4 or 5 or 10,000 feet because, well, the face doesn't go that high. Similarly, the lowest they're going to go is 0. At 0 feet, that's when they're starting their climb. They haven't climbed anything yet. So all the numbers that we're going to get have to be between 0 feet and 3,000 feet. If we get an answer that's bigger than that or smaller than that, we've gone too far. And it won't fit this particular problem. So again, in the equation, the standard, this is called slope-intercept. Slope is the letter M. Intercept, they use the letter B. And again, as I said, I don't know why they chose M and B. I'm sure it's in a different language. It makes perfect sense other than English. The words probably start with the letter M and B. But in the English language, using an M for slope doesn't make a lot of sense, nor does using a B for where the y-intercept, where it crosses. In ours, the y-intercept is the 1,500. B and 1,500 they coincide. And our rate, or slope, in this problem is positive 20. Positive 20 feet per minute, where X is number of minutes. So if you give me an input value, a number of minutes, I can give you an output value, a height. Or if you give me the output value, I can use it to find the time of either before I arrived or after I arrived. So this is the equation we're going to use on the next page. This Y output, or height in feet, equals 20 feet per minute plus where the initial value, the 1,500 feet. When we arrive, when time is 0, 20 times that 0. If I substitute a 0 in here for when we arrive, I could go Y equals 20 times 0 plus 1,500. Slide that over a little. And 20 times 0, we all agree is 0, still plus 1,500. That equals Y. So Y equals 1,500. So when at the start of the climb, when X is 0, Y is 1,500. The climbers are at 1,500 feet. That's what this relates to. X and Y will change. Again, if you give me an X, it gives me a different Y. These are the only two numbers I really have to find for this equation. The slope and the y-intercept, or what value is Y when X is 0. So let's go on to the next page and take a look at those problems. Use your equation. Use your equation to determine how long after 11:30 a.m. it will take the climbers to reach the top at 3,000 feet. What time would the climbers reach the top? So again, there's a few problems in one here. The equation we're going to use still is this one, Y equals 20x plus 1,500. Again, Y is height in feet, X is time in minutes. So this is the equation. Now, let's take a look. Use your equation to determine how long, so we want to know how many minutes it takes the climbers to reach a height of 3,000 feet. So for this portion of the problem, if Y, height in feet, is 3,000, then the equation 3,000 equals 20 times x plus 1,500. Subtraction property of equality, I'm going to subtract 1,500 from each side. And that leaves me 3,000 minus 1,500 is 1,500 equals 20x. Well, 20 is being multiplied by x. I need to divide both sides by 20. The division property of equality. 20 divided by 20 is 1. 1,500 divided by 20 is 75. So from when we arrive at 11:30, 75 minutes later, these climbers reached the top of 3,000 feet. So it took 75 minutes to reach the top after we arrived. What time is that? Well, we arrive at 11:30, and 75 more minutes is an hour and 15 minutes. So if we arrive at 11:30 and it took 75 more minutes to reach the top, then 11:30 plus our hour and 15 is 12:45 in the afternoon. So that's the time the climbers reach the top. Again, there's a few problems in one here. Use your equation to determine when the climber's at 1,400 feet. What does this answer mean in terms of the problem situation? Well, again, 1,400 feet is before we arrived, because when we arrive, they're already at 1,500, so 1,400 took place before we got there. So I'm going to put the height, 1,400 feet is 20 times 20 feet per minute times the number of minute plus 1,500. Same setup, same problem, same equation, and very similar how we're going to solve it. I'm going to start subtraction property of equality because I need to get x all alone. X has a 1,500 that's being added. I'm going to subtract 1,500 from both sides of the equal sign. Subtraction property of equality. When I subtract 1,500 from 1,500 minus 1,500 is 0. That just disappeared. 1,400 minus 1,500 is negative 100. 20 times x is negative 100. Well, I'm going to divide both sides by 20. Division, property of equality. 20x divided by 20 is x. Negative 100 divided by 20. Negative divided by a positive is a negative. 20 or 100 divided by 20 is 5. So negative 5 minutes. That negative means 5 minutes before I arrived. That's what the negative means in this case. And 5 minutes before we arrived, if it was 11:30, 5 minutes prior to that is 11:25 a.m. So hopefully it's making a little more sense. And again, if it doesn't, don't panic. We're going to be working on this for a while. And again, your 8th grade teacher, your 9th grade teacher is going to be going over a lot of the same information. Just if it makes sense, fantastic. Because the earlier it makes sense, the more confidence you have, you're able to explore other things, and everything seems friendlier and easier at that point. Math goes from impossible to easy, just as it makes sense, but then the nature of mathematics, you're with the next topic that seems impossible, well, until you learn that. Use your equation to determine how high up the cliff the climbers were 2 minutes before 11:30. So 2 minutes before is negative 2. I'm going to plug in negative 2 for x. Y equals 20 times negative 2 plus 1,500. 20 times negative 2, positive times negative, negative. 20 times 2 is 40. So y equals negative 40 plus 1,500. Combine these two, 1,500 minus 40 is 1,460 feet. So 2 minutes before we arrived, the climbers were at 460 feet. A half an hour before 11:30. Well, a half an hour is 30 minutes, and before means negative 30. So let x equal negative 30, and let's simplify it, or let's solve for y. Height, y, equals 20 times negative 30 plus 1,500. 20 times negative 30, positive times negative, negative. 20 times 30, 600. Y equals negative 600 plus 1,500, or 600 bad guys, 1,500 good guys, have a shootout. Good guys win. There's 900 of them left, because this is 1,500 minus 600. So a half hour before we arrived, the climbers were at 900 feet. Number 9, use your equation to determine how many minutes before 11:30 the climbers started the climb. What time of day was that? So we want to know how many minutes, and then we want to subtract that from 1130. And again, when they started their climb, they were at 0 feet. And so y is 0 feet. 0 equals 20 feet per minute times the number of minute plus 1,500. Again, we're solving for x. So I'm going to subtract 1,500 from both sides, subtraction property of equality, and I get negative 1,500 equals 20 times x. Divide both sides by 20, division property of equality. Negative divided by positive is negative. 1,500 divided by 20, negative 75 minutes is x. So they started their climb 75 minutes before 11:30. And what time is that? 11:30 minus an hour and 15 minutes, because again, 75 minutes is an hour and 15 minutes. They started their climb at 10:15 in the morning. So all of those, we represented the situation with an equation. Now we're going to move over to a graph. I always fall back to my equation because that's my go-to. And so that's the one that I find the most comfortable to use. So I'm putting the equation again up here just because I might end up using it again. So output, height in feet is 20 times x plus 1,500. Now that you've represented the situation with an equation, represent it with a table and a graph. So I've got my table over here. Tables can be vertical, up and down, or they can be horizontal. Just make sure you're paying attention to your x and y's. The units of measure, well, time, the unit they gave us for time was in minutes. The unit of measure in height was in feet. The variables that we used, and again, you might have used different variables, and that's okay. I used x to represent time in minutes, and I used y to represent feet, height in feet. How high at 0 minutes when we arrived? Well, the high climbers were at 1,500 feet. 2 minutes or 2 minutes after we arrive, positive 2, we had that on this problem. And so I just went, hey, at 2 minutes, they were at 1,540 feet. So I just wrote in 1,540. At 15 minutes, we had that as well, but I just plugged it in just to show you. Y equals 20 times 15 plus 1,500. Y equals 300 plus 1,500. Y equals 1,800. So they were at 1,800 feet. At an hour, and again, we had that one as well. In 1 hour, they were at 2,700 feet. And at 75 minutes, these ones I get to choose. I chose 75 minutes because that was another one we knew. That 75 minutes after we arrived, they reached the peak. So they're at 3,000 feet. And then I just went with the opposite of 2. I went with negative 2. If positive 2 was plus 40, negative 2 was 1,500 minus 40. If 15 was 300 more than 1,500, 1,800, then negative 15 is 300 less than 1,500. They were at 1,200 feet. If 60 minutes was 1,200 more than 15 at 2,700 feet, then negative 60 is 1,500 minus 1,200, 300 feet. And if it took 75 minutes to reach 3,000, then 75 minutes ago is when they started. Then I graphed the points, the coordinates. And again, at 75 out here, or excuse me, negative 75, I just happen to do mine in red to show before I arrived in red. They were at 0 feet. So again, my x-coordinate down here is 0 feet in height. And that's when, this is 75 minutes before we arrive. So that's the coordinate negative 75, 0. When we arrived, they were at 1,500 feet. So when we arrived 0 minutes, they're halfway up the climb. 75 minutes after we're there, they're at 3,000 feet. And this is a continuous line because the climbers do have to climb every single inch, half inch, thousandth of an inch. It's a continuous line from negative 75 to positive 75 on x as x changes. The y value, the height, Goes from 0 feet all the way up to 3,000 feet. And so I put in some of my coordinates from over here. I didn't put in the 2, I could have, but it was so close to the 0, the 2, it was just going to mess up my coordinates that I would try to list for you. Because I put on when x is 60, y is 2,700. When x is 15, there's 10, 20, so 15 is halfway, y is at 1,800. When x is at negative 15, y is at 1,200. When x is at negative 60, y is at 300. When x is at negative 75, y is at 0. What should be the leftmost point on your graph? Explain your reasoning. The leftmost point goes this direction. So I just did the arrow. And the point there is negative 75, 0. That's 75 minutes before we arrive. That time is 10:15. And the 0 is 0 feet in elevation. The climbers are just beginning, so they're at 0 feet of their climb. What should the rightmost point on your graph? Or what should be the rightmost point on your graph? Again, rightmost goes this direction. And on our graph, the rightmost point is at 75, when x is 75. Y is at 300. The 75 is 75 minutes after we arrive, which is 12:45 in the afternoon. The 3,000 feet elevation means the climbers reach the top, so they've reached the peak. Locate the coordinate negative 60. What is the height of the climbers at this point? Well, when x is negative 60, the height was 2,700 feet. And we have that in our table, but I just solved it. Negative 60. I lied because I left out a key negative sign there. That will teach you. So, should have been at negative 60, 300 feet. I'm going to have to blame somebody for my mistake because I don't make mistakes. So clearly a student caused me to make it. Who to blame this time? Who's my usual go-to on students I blame for when I make the mistakes? All right. On B, write this point as an ordered pair. So that should have been 300. So 60 minutes before we arrive, the climbers are at 300 feet. This analysis of the climber's progress assumes that the climbers would climb at a steady rate of 20 feet per minute. In reality, would the climbers be able to do this during the whole climb? If not, how might the graph reflect this? And again, 20 feet per minute is an average. So 20 feet per minute would be their average rate. Some sections are easier, so they can climb faster. Some sections are more difficult, or the climbers just are tired and need to catch their breath, so they need to slow down. In actuality, as they sped up, it would give us a steeper graph. Steeper graph would mean faster. Flat graph means they stopped. And less steep graph means slower. So as they climb, if they're climbing fast, it might be a steeper graph. They stop for a little bit. They go slow. They speed up. They stop. Go slow. Go fast. And it would be this jagged line all the way up from start to stop. But the average would average 20 feet per minute. And then explain what negative values of time represent. The negative values are the negative times are the number of minutes before you arrive to watch. So negative 10 means 10 minutes before you arrive. So the negatives just mean prior to you getting there. Talk the talk. You've represented two situations 4 ways: as a sentence, as a table, as a graph, as an equation. Complete the graphic organizer and explain the advantages and disadvantages of each representation. Think about the type of information each representation displays. Also think about the types of question you can answer using representation. And again, early on, when we first went into this section, as we were going into it, my introduction video, M3, Module 3, Topic 3, Lessons 1 through 4, Introduction, I talked about all 4 of these. I basically did this page in that video. And so you can go back and review the video, because if you go through it now, certain things should make more sense to you as you go through it, having gone through this section. And it might reinforce some of the topics we've gone over. It asks for a sentence. Again, an advantage of sentences. The sentences are word problems. They show real-world application. They help show information you need to understand in context of the problem. Again, climbers, height, feet, before you arrive, after you arrive. They put context and meaning. Disadvantage, they make it difficult to apply effort to see what's happening as things change. One of the hardest part of math is taking a word problem, a sentence, and turning it into a workable table, equation, graph that you can use and apply to other things. Tables or charts. They give me specific values to work with, and they can help me see patterns, but they're not that helpful in finding the other values, and especially the values in between the values in a graph, or fractions, decimals, percents. It's hard to find those from just a few concrete examples. It's hard to know how to calculate from them. Graphs. And graphs, they're great for displaying a big picture of data, patterns, and trends. You can see how things are changing on a graph. They give you a lot of information in one picture. But the points on a graph are hard to use to determine the exact values. We can often use the points that hit perfectly where lines intersect, but if they don't perfectly intersect on the corners of, like where X and Y's meet, like these perfect numbers, if they're in between, it's just an educated guess where the numbers are. You can be close, but that's all you can be. So the disadvantage is they're not very precise. And then equations. These are my personal favorite. An advantage of equation, they help me generalize a pattern, and they allow me to calculate exact values. So again, equations don't give you specifics towards a particular type of problem or a word problem. They don't make real-world sense often, where if you see an equation, you might not know how to apply it to the real world, especially at first. And that is a disadvantage. The disadvantage, they don't provide a visual representation to see patterns, and they don't provide context that allows you to see applications in real life, but they're great for generating exact values. If you can put a sentence into an equation, then you can get everything else you need. Or if you can take an equation and just make up a problem, make up a word problem for it, that's also challenging. You can find exact values with that. And really, those are the pages that we've covered. I would advise going back through the video again, that Module 3, Topic 2, Lesson 1 through 4, Introduction, and where I started, with a sentence, and I used the sentence to generate an equation, a table, a graph, or they give me a table and I use it to generate the other 3. Because that's really where we want to be able to go. You're going to be given one of these 4, and we're going to want you to be able to turn it into the other 3 and know what you're looking at. To be able to take a graph and make a a word problem that fits it, create a table, and create an equation for it. And so I did examples of that, and you've now done, through this section, some examples of it, where we were working with the climbers. And what was the first earlier problem we were working with before even the climbers? In the earlier section, we were working with Mrs. Jackson, who translates pages. So she'll turn material into another language. And that was where she charged $25 per page, but she charges a $325 fee just for taking on the job. And so that is this section, the Module 3, Topic 3. We're finishing up Lesson 1. And so there is an Edulastic that goes with it, the Edulastic quiz. And good luck with that. And let me know if you have any questions or concerns.